Hi, I'm Shyamala Gauri, Assistant Professor in Rohini College of Engineering and Technology. Subject code CS3352. Subject name Foundations of Data Science. Unit 5 Data Visualization. The topics to be presented here are text annotation and three-dimensional plotting. Text annotations. The most basic types of annotations we will use are axes, labels, and titles. Here we will see some more visualization and annotation and informations. Text annotation can be done manually with the plt.text of ax.text command, which will place text at a particular x bar y value. The ax.text method takes an x position and y position as string and then optional keywords specifying the color, size, style, alignment, and other properties of the text. Here we used HA is equal to right and HA is equal to center, where HA is short for horizontal alignment. Transforms and text position. We anchor our text annotations to data locations. Sometimes it is preferable to anchor the text to a position on the axis or figure independent of the data. In Matplotlib, we do this by modifying the transform. Any graphics display framework needs some scheme for translating between coordinate systems. Mathematically, such coordinate transformations are relatively straightforward, and Matplotlib has a well-developed set of tools that it uses internally to perform them. The tools can be explored in matplotlib.transforms submodule. Transforms and text position. There are three predefined transforms that can be useful in this situation. First one, ax.transdata. It transforms associated with data coordinates. Second one, ax.transaxis. It transforms associated with the axis in units of axis dimensions. Third one, figure.transfigure. It transform associated with the figure in units of figure dimensions. Here is an example program that shows how to include text annotation in the plots. See, here plt.style.use of seaborn white grid is used, and then plt.subplots have been called. And to transform data, we have used ax.transdata, ax.transaxis, figure.transfigure. The output is shown in the next slide. Here, here it shows, this figure shows the output for the previous program. Next one is 3D plotting. We enable 3D plots by importing the mplot 3D toolkit included with the main Matplotlib installation. The example program and its output is shown here. Here mpl.toolkits imported from mplot3d. Here plt.figureof function is called and plt.axis is called and projection is equal to 3D. The output is shown on the right side of the slide. 3D points and lines. The most basic three-dimensional plot is a line or scatter plot created from sets of x, y, z triples. In analogy with the more common two-dimensional plots discussed earlier, we can create these using ax.plot3d and ax.scatter3d functions. Here is an example program to show the use of ax.plot3d function. Here mpl.toolkits is imported from mplot3d and projection is equal to 3d. data for three-dimensional line has been filled, and then data for three-dimensional scattered points has also been filled. That is x z data, x data, and y data are filled. The output is shown on the right side of the slide. Next, 3D contour plots. mplot 3D contains tools to create three-dimensional relief plots using the same inputs. Like two-dimensional ax.contour plots, ax.contour 3D requires all the input data to be in the form of two-dimensional regular grids with z data evaluated at each point. Here we will show a three-dimensional contour diagram of a three-dimensional sinusoidal function. Here is the example program. mpl.toolkits is imported from mplot3d, and then x, y, and z functions are defined, and ax.contour3d of x, y, z have been specified. The output for the given program is shown on the right side of the slide. Next, wireframes and surface plots. The other two types of 3D plots that work on graded data are wireframes and surface plots. These plots take a grid of values and project it onto the specified 3D surface and can make the resulting 3D forms quite easy to visualize. A surface plot is like a wireframe plot, but each face of the wireframe is a filled polygon. Here is an example program how, to show how to create a wireframe plots. mpl.toolkits, it's imported from mplot3d, and plt.figureout function is called plt.axis. In that, projection is equal to 3d. Here ax.plot.underscore wireframe xyz, and color is specified as black, and then ax to set the title ax.set underscore title wireframe, and the output for this given program is shown on the right side of the slide. Thank you.